Hey, mathematics worksheets don't grow dendrites. Now the idea here is that in the brain, we're going to get into this a little bit longer, but a little bit later, but there's the structures in the brain that hold our intellect are called dendrites. And Marcia Tate argues that mathematics worksheets don't grow dendrites. These worksheets that I know over the years with my kids, they come home and the math homework, okay, what's your math homework? And it's a page of 50 long division problems. And I'm not just talking about long division, I'm talking about long division. Why do we have to do 50 long division problems? That does not grow dendrites. In fact, here's what Marcia says. She says the person in the classroom doing the most talking about the content is growing the most dendrites, these brain cells that hold the intellect. So who's growing the most dendrites in the typical classroom in America? Teachers. A large number of teachers grow dendrites daily since they are the ones talking about the math. And she says whether you are instructing a whole class or having students work in small groups, doesn't matter. Learning is facilitated when instructors ask open-ended questions. And that left parietal lobe can be activated, and they can have ideas, and they can throw them out to the public forum. Encourage a variety of ideas as students engage in interactive discourse. Now, if you just kind of get into the whole dendrite thing, let me just give you a little bit of background on it. The significance of dendrites in the neocortex in the brain is that their neural networks are the basis of human intelligence. And according to research, these dendrites increase with use and decrease with disuse. Use it, lose it. It's true. So we need to get that brain actively engaged, not passively just hanging out in the class to get those dendrites to grow. There's no limit, however, to the human capacity to learn more. Neurons are continuing to make new connections on a day-to-day basis throughout our lifetime. For those of us who are teaching here, and you get those returning students, you have them. What do they say? Oh, I'm too old. I can't learn this anymore. And I said, no, sorry, the brain research does not support that. You have the capacity to learn more forever. As long as you're breathing, as long as you're producing CO2 red, they can grow dendrites.
Well, the problem is as you decay, you also produce.
If we're learning passively, dendrites won't create enough neural networks for enhanced learning. Active learning, Melinda, here it is. Active learning, the continual use of the brain in experimentation and dialogues is essential because our brains will create new neural networks that override pre-existing ones to help us make more connections, become more intelligent, and process more information. We must be active. Even if it is, I'm trying to keep this short, but even if it is in a lecture situation, are you actively engaged right now? Is your brain right now taking it in, connecting it, thinking about it, disagreeing with it? And at the end, I'm going to give you a chance to throw out some ideas. David Sousa has, he's one of the big guys in the brain research world. Just as phonemic awareness is a prerequisite for learning phonics, becoming a successful reader, developing number sense is a prerequisite for succeeding in mathematics. I'm teaching the Math 156, the elementary teacher mathematics right now. Guess where we started? Place value. Oh boy. And at the beginning, they could talk about place value for about 4 seconds. That's all they had. Today, they turned in an assignment I call it the Show You Know, and they had about 5 pages talking about place value. It was wonderful. I had goosebumps. 7 of them right there. No. Children in the primary grades encounter a sudden shift from their intuitive understanding. Remember, we all have that left parietal lobe. We all have a fundamental ability to do math. This number sense, it's natural. Children in the primary grades encounter a sudden shift from their intuitive understanding of numerical quantities and counting strategies to the rote learning of arithmetic facts. Unfortunately, most children lose their intuition about arithmetic in the process. There's a sort of a famous study, at least in my world, that says second graders. Beginning of the year, they go in there, researchers go in there, they give second graders some math problem to solve, and those second graders dig in. They try this, they try that, they draw a picture, they talk to their neighbor, they get out some manipulative, they'll try anything to try to solve the problem. At the end of second grade, the researchers went back into the classroom, pulled the second graders together, gave them a math problem, and the second grader said, "We can't do that one. Teacher never showed us how to do that one." Just in 1 year, their natural ability was like beaten out of them because they learned that mathematics is about following rules, getting the right answer, and either you know how to do it or you don't. It's not about trying to make sense and trying to figure it out. And so we need to do something about it. Now, this doesn't support the brain research. Working memory has a capacity. There's time limits. Teachers should keep in mind that we should keep it short. Less is more. Shorter is better. Now, If you have a 90-minute block period, we're not saying you should cut that down to 10. We're saying that within that 90, you should do a little bit of this, a little bit of that, a little bit of this. And keep things moving, keep things active. Information is most likely to get stored if it makes sense and has meaning. If it doesn't make sense and have meaning, we might be wasting our CO2. So somehow we have to get students involved in making sense of what they're doing. That has to be the premier thing that happens every single day, is that people are trying to make sense. If a teacher cannot answer the question, why do we need to know this, in a way that is meaningful to students, we need to rethink why we're teaching that thing at all. Now I know we live in a world that we have aims and Common Core standards and everything else, but really, if we really want to follow brain research and get at how the brain really learns, we need to answer that question in a meaningful way. There's a wonderful book, actually there's a free PDF online, Google Mathematician's Lament. A wonderful little article that now has been turned into a book, and in it, Paul Lockhart kind of laments about the current situation of mathematics education, and he would say things like this: by concentrating on the what and leaving out the why, mathematics is reduced to an empty shell. And he would say the art is not in the truth of the thing. Like, area is 1/2 base times height. That's not what it's about. What it's about is the explanation, the argument behind why area is 1/2 base times height. In fact, it comes up, I think, here. Mathematics is about problems. Problems must be the focus of a student's mathematical life. And this is important to me. Painfully and creatively frustrating as it may be, students and their teachers should at all times be engaged in the process. Learning is not easy. If we think that our jobs are to go out there and try to make life easy for our students, they're probably not going to learn a whole lot. The whole learning process, those dendrites growing, the growing process in general can be painful and frustrating. If it's painful, I tell my students all the time, if you're feeling pain and frustration, you're learning. I'm doing my job. Having ideas, not having ideas, discovering patterns, making conjectures, constructing examples, that's what they should be doing. Devising arguments. That's what the show you know was. They had to argue. They in class had done different place value things, but the show you know put them in brand new environments they had not been in before. They had to explain and argue why the place value worked this way if it was base 7. It was awesome. The truly painful thing about the way mathematics is taught in schools, now this is Paul Lockhart speaking here, it's not just about what is missing, the fact that there is no actual math being done. He argues that mathematics is about the conjecturing and the problem solving and etc. So he says there's no math actually being done. And also, what's in the place of what we call mathematics? It's a confused heap of destructive disinformation known as mathematics curriculum. And his example of that is, the area of a triangle is 1/2 base times height. Students are asked to memorize this formula and then apply it over and over in the exercises. Gone is the thrill, the joy, even the pain and frustration of the creative act of where does that 1/2 base times height come from? The question has been asked and answered all at the same time. There's nothing left for the student to do. And usually when they have these problems, the exercises are, there's 2 facts that they're given. And there's 2 places to plug them into the formula. So there's really no thinking to do, you just gotta hurry up and get it done. Now, I was going off to do a presentation. I was going to include my brain research thing about a year ago, and just before I left, I opened up the newspaper, the Arizona Republic, and they answered all my questions. Electrical brain stimulation may boost math skills. Yes! I can quit my job. Adults did better on tests after painless therapy, but more research is needed. All right, here's what the article says. Those of you who are lousy at math, already I'm reading the article, oh no, wait a minute. Those of you who are lousy at math, does that jive with current brain research? But you gotta keep reading. Those of you who are lousy at math may someday be able to boost your skills. Now what do you think they mean? Boost your skills.
Rules.
You can do the rules better. You can do like, you can square 312 in your head or something. Like something really useful like that. But you can boost your skills with the use of a painless method of electrical brain stimulation. Adults with normal math abilities are able to improve their performance on a series of numerical tests with the help of non-invasive technique known as transcranial direct current stimulation. So I got it set up. I went to the, what's the thing we have to go through to do research? What's that board called? It's the
Human subjects.
Human subjects thing. Yeah, I went to human subjects and we got all set. I got my classroom wired. When the kids sit in their desk, they put these little probes on their head. And when they go, wait, I don't understand, I just go, and we're going to test to see if it's true. And if that gets denied, if it's too expensive, then Leonard has promised to come up from college safety with his taser. So, I don't know about all this, because now they're talking about math, and I think they're talking about computation and procedures and skills and memorizing, and maybe we can boost that with some electrical stimulation, I don't know. But I don't think they're really talking about mathematics the way I'm thinking about it. So, you have a partner, right?
No. Yes, sorry.
Would you please share one thing, or two things, or three things that you thought were interesting, you disagree with, whatever. I'll give you some time to share
Yeah,
this.
talk to me.